Transformations Part B. Now that we have learned how to do a vertical shift and a horizontal shift, like where the parent function goes when it slides somewhere, we're going to look at a couple different transformations, a couple more transformations. So just remember, we have the linear function, a quadratic function, a root function, an absolute function, a cubic function, and an exponential function. These are our parent functions, and we're going to do transformations to these parent functions. Alright, so you saw this from the last video when we have something on the inside. Remember, the inside lies and you go left or right, so in this case I'd go left 2. Remember, the outside, it tells the truth, so it's going to go up or down. Pull this out from behind the video. Sorry, hold on just one sec. There. So that one, in this case, went up 4. Now we're adding stuff up here in front of our function. So if it's a number, the number is a vertical stretch, is what it's called. So in this case, there's a 3 in front, and that's a vertical stretch of 3. So it's basically going to take your graph, and it's just going to kind of stretch it out. If that were a fraction, we're going to just call that a vertical stretch of 1/2, but instead of stretching it this way, it's kind of like we're squishing it, and it goes down. It's also known as a compression, but we're just going to call it a vertical stretch for now. And then there's going to be times where we have a negative out in front. If there's a negative, what it's doing is it's flipping your function. And more specifically, it's going to flip your function over the x-axis. So if you had a graph like this, it would flip it, and it would end up looking like that instead. Okay, so it gets flipped over the x-axis. So we're going to look at some of these problems to identify the transformations, and then we're even going to graph a couple of them. So let's go ahead and go on to the first example. So we have right here, first off, what is my parent function for this one? Well, my parent function is the absolute value. And what are the transformations? Well, this x minus 4 is on the inside, so that's telling me I'm going to go to the right 4. And then we got this 2 sitting on the outside that's being multiplied to the front. What that is going to do to my graph is it's going to make a vertical stretch of 2. Okay, so if I'm just identifying the transformations, that's what I would do right there. Okay, let's try another one. Alright, now this one, what is the parent function? Well, the x is underneath the square root, which means this is a root function. Okay, the x minus 6 is inside, because it's underneath the root. So that's going to lie and tell us that we're going to go right 6. And then if you notice, we have this negative out in front. Remember, the negative is going to flip over the x-axis. So that would be the transformation for this function. Okay, next. First off, what's the parent function? Well, here's the x, and the x is being squared. Therefore, this is a quadratic function. What are the transformations? Okay, on the inside lies. So this plus 2 is telling me I'm actually going left 2. On the outside, this does not lie, and it tells me whether I'm going up or down. So in this case, I'm going to be going up 1. Okay, and I have the 3/4. Remember, the number in front makes it a stretch, or more specifically, a vertical stretch of, in this case, 3/4. So since it's less than 1, what it's going to do is it's going to take that quadratic graph and it's actually going to kind of squish it down a little bit. So we got a vertical stretch of 3/4. Okay, now let's combine all of that. It looks like here we have a cubic function, because it's x cubed. Okay, the inside is telling me I'm going to go right 4. The outside is telling me I'm going to go down 8. The 2 says I'm going to have a vertical stretch. I'm just going to kind of use shorthand here. Of 2. And then the negative out front right there tells me that it is a flip. over your x-axis. Okay, so there's 4 different transformations happening to that equation. It used to be just a regular old cubic function, and then all these transformations took place. Alright, so now let's look at graphing these. So we're going to take the knowledge that we have, and we're going to try to graph them. So first thing I notice when I'm looking at this equation is I know it's a quadratic, because it's squared. So I know it's kind of like a little smiley face looking thing. Now remember, I usually start at 0, then go up at 1, 1, and then 2, 4, and then negative 1, 1, and negative 2, 4. However, this time I have to shift left 3 and down 1. So I'm actually going to be starting from right there. Now, just like from the normal one, we'd normally go through this point, and we'd normally go over to up 4, and go through this point, over to up 4. And that's what our graph would look like. However, there's a negative. So what that means is that all these points are actually going to be flipped. We're going to be going the other direction. So we're actually going to be going down this way. That is not a very good drawing, but hopefully you get the point. So we went from this graph, so normally, remember the graph, let's see, normally the graph would come right here, and then come up. Should look more like a U. But this time it shifted over, shifted down, and then flipped. That's what all my transformations did that took place. Okay, let's try a square root. Remember, a square root function usually starts at 0, 0. And remember, the square root of 4 is 2, so if I went over to 4 and went up 2, this would be my normal graph. The square root of 9 is 3, so if we really wanted to, we could do 4, 5, 6, 7, 8, 9, and have it at 3. So it just kind of goes slow incline. Okay, that's the regular parent function, but now we have all these transformations. So this tells me I'm going to go left 3, down 2. So 1, 2, 3, down 2. 1, 2. Okay, and typically I would go over 4 and up 2 because that's what I did for this one. However, this time I have a stretch of 2. So because of the 2, we can't just go through that point. We actually need to plug in a point to see where it's going to go through. I think it's easy if you just plug in a 0. So for example, let's just plug a 0 in here for x. So 0 plus 3 is 3. Actually, let's make it even more convenient. Let's see, we know what the square root of 4 is. So let's make x a 1. Okay, and 1 plus 3 is 4, and the square root of 4 is 2. So we have 2 times 2 minus 2. 2 times 2 is 4. 4 minus 2 is 2. So what that tells me is that when I'm at x is 1, I'm actually going to be going through this point right here. And so that's just going to kind of stretch it. And it kind of makes it a little less steep, or a little more steep, I guess I should say. It takes it from being flat. And then, since I times it by 2, it's going to stretch it up a little bit. So it's going to make it so it's not as steep. So it's steeper. I'm sorry, I keep saying that backwards. See, this is kind of a flatter one. Here we get a little bit more of steepness. So to be able to find another point, I would just plug in a number for your x to figure out where the next point on your graph is for this particular case. So let's try this one as well. So once again, we have a quadratic graph. So usually we'd be at 0. And we go up through 1, 1, 2, 4. This one's going to be a little bit different. So first off, let's go ahead and do our transformation. So we're going to go left 4, up 2. So left 4, up 2. And this is where I'm going to start. But now, I'm timesing it by 1/2, so it's going to kind of squish it. So let's go ahead and pick an x value. Let's go ahead and pick 0 right here. 0 plus 4 is 4. 4 squared is 16. Okay, and we're going to take half of that, because we bring down the 1/2. Half of 16 is 8. 8 plus 2 is 10. Okay, But the negative out here, we need to make sure we have a negative. So my new point is going to be at 0, negative 10. So I just pick an x and plug it in there. So in this case, if I plug in 0, I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is a symmetrical graph, so since I went right, 1, 2, 3, 4, if I go left, 1, 2, 3, 4, I'm actually going to get the same thing right there. So this is approximately what my graph would look like. So go ahead and work on your assignment, and feel free to email me if you have any questions.